in this case when the angle is in the first quadrant. So what I mean by first quadrant is this one where the angle is between 0 and 90. Okay, so this is how you normally had trig working. This isn't necessarily true once we go outside the first quadrant when angle is greater than 90. So we're going to look at an angle that is in another quadrant. Okay, so let's do this one over here. Let's say that's -4, -3. Okay. So if that's the coordinates of that point, so that's x and y, and we have to find out r. So r equals the square root of x squared plus y squared, which is -4 squared plus -3 squared. And that's going to be the same as before, so that's going to give us the square root of 25, which equals 5. Okay, so that's r equals 5. So now we can find cos theta, or sine theta, cos theta, and tan theta. So sine theta, sorry I didn't mark what theta was. Theta is this from the positive x-axis to the terminal arm. And you can see that it's greater than 180 degrees. So sine theta equals y over r. So -3 over 5. Cos theta equals x over r, so -4 over 5. And tan theta equals y over x, so it's going to be -3 over -4, which equals 3 over 4. Now on your calculator, if you try to find this angle by using sine inverse, we're going to have a bit of a problem. Okay? So sine inverse, so if you want to find theta equal to sine inverse of -3 over 5, on your calculator, you get sine inverse -3 divided by 5, and you'll get -36.869 degrees, which is clearly not the answer. Okay, so it's not down here. So that'll give you a negative number, a negative angle. .9 degrees. So that's not very helpful. So this is where the related acute angle comes in handy. So the related acute angle is in here, and we call it alpha. Okay? And if we look at this triangle here, we know the side lengths of that triangle. We know that this side length here, if we forget about the negatives, this is this is 4, this is 3, and this side is 5. And if you know 3 sides of a triangle, and you know that it's 90 degrees, you can figure out an angle using just basic trig. Okay? So if you figure out alpha, how could you figure out theta? Well, theta equals 180 degrees, which is this one here. So there's 180 degrees plus alpha. Okay? So theta equals 180 plus alpha. So if we can figure out what alpha is, then we can figure out what theta is. And the way we can figure out what alpha is forget about the signs. So I imagine that this is in the first quadrant. Just forget about the signs and just solve this triangle. Solve for that angle in this triangle as if these are not negatives. Okay? So I can write sine of alpha equals 3 over 5. So then alpha equals sine inverse of 3 over 5. And on your calculator, sine inverse of 3 divided by 5 is 36.9 degrees about. Okay. So that would then make theta equal to 180 plus 36.9. Okay. And that adds to 216.9. Okay. And we can check this. So on the calculator, you could take the sine of 216.9 degrees and see what it gives you. So sine 216.9, oh, it didn't go in properly. And it gives me negative 0.6. And 3 over 5 is 0.6. So negative 0.6 would be right. Okay, so this is how we have to figure out the angles now when they're greater than 180. We have to look at the diagram, figure out what quadrant they're in, and add or subtract 180 or whatever. If the diagram, or if the angle, the terminal arm was in this quadrant here, instead of adding 180 to alpha, you would subtract alpha from 180. Okay? So let's take another look at one. So example 3. Let's take a look at one in that quadrant. Okay, so make that point negative 2, 5. Okay. And here's the angle, standard position. And R is going to be square root of negative 2 squared plus 5 squared, which equals root 29. So not as nice as the last one where it was root 25. So we're just going to leave it as root 29 so we have exact values. Okay, so sine theta is going to equal 5 over root 29. Cos theta equals negative 2 over root 29. Tan theta equals 5 over negative 2. Just write as negative 5 over 2. Okay. Now if we want to find out what that angle is, drop a perpendicular down. This is greater than 90, but less than 180. So if I can figure out what alpha is here, then I subtract it from 180 and I will get theta. Okay. So in this case, theta is going to be 180 minus alpha. So we just need to find alpha. And to do that, we just forget about the signs on these. So we can just say sine theta is 5 over root 29. It's already positive, so we don't have to worry about that. We can just find that. So sine of alpha equals 5 over root 29. Which means alpha equals sine inverse 5 over root 29. And when you use your calculator, you'll get 68.2 degrees. That means theta, that's approximately that, equals 180 minus 68.2. And you get 111.8 degrees. Okay, next example is going to be in this fourth quadrant here. So the way we define our quadrants is, this is quadrant 1, 2, 3, and 4. Okay. So let's let that be the terminal arm for this example. Say 6, negative 5. So there's theta. And that's going to be greater than 270, but just less than 360. And r is going to equal square root of 6 squared plus negative 5 squared. And that ends up being the root of 61. Sine theta equals negative 5 over root 61. That's the y over r. Cos theta is 6 over root 61. Tan theta equals negative 5 over 6. Okay, put alpha in here. Drop the perpendicular. Okay, so alpha is with the closest x-axis. And now I can use, I tend to want to use the one that's positive here because it's like it's in the first quadrant. So cos theta is 6 over root 61 to find the angle. Well, cos alpha is also 6 over root 61. Okay, so if I look at alpha, cos of that angle is adjacent, which is 6, the x is 6, over the hypotenuse, which is root 61. Okay, so alpha equals cos inverse of 6 over root 61. And that would give us 39.8 degrees, approximately. In this case, we're going to subtract alpha from 360 to get theta. Okay. So theta equals 360 minus alpha. Okay. And that would be 320.2 degrees.